Apart from using the sine rule to solve triangles which are not right angle triangles like the obtuse angle triangle and the acute angle triangle, we can also use the cosine rule to solve triangles which are not right angle triangle. Let me write that out. The cosine rule. So what we'll do here is we'll try to prove the cosine rule and using the obtuse angle triangle and the acute angle triangle. So let's say we have our acute angle triangle as this. Let's say our acute angle triangle looks like this, like this, like this, like this, okay, like this. So now let's say this is angle A, this is angle B, and this is angle C here. I'll just produce this down, no, this doesn't look straight. Yeah, okay, this is looking straight. So let's say this is angle 90 degrees here, and let me just put this as K. So the height AK, let's just put it as small letter h. Then we know that because the angle A is facing the side AC, let's put this as small letter B. Let me use another color, small letter B. Now since the angle C is facing the side AB, let's put this as small letter C. Now since the angle A is facing the side BC, let's put this as small letter A. Small letter A. Now, since this is CK, we can just put this here. The distance CK, we can put this as X. Now, if this is X, it definitely means that BK will be A minus X, because if, for example, A is 5 meters and X is 2 meters, you would expect BK to be 5 minus 2, which is going to be 3 meters. Now, from this, we can just say in triangle ABK, that's this triangle ABK. Now we can use the Pythagoras theorem, which says that the hypotenuse squared of any right angle triangle is equal to the sum of the square of the two other sides. So the hypotenuse here, this is 90 degrees here. The hypotenuse here is this side AB, which is C. So we'll just say C squared is equal to the sum of the square of the two other sides, which would be A minus X squared plus H squared. Now let's expand A minus X squared. A minus X squared is still the same thing as A minus X and A minus X. So just say A times A here will give us A squared. A times minus X here will give us minus AX. Minus X times A will give us minus AX, and minus X times minus X give us plus X squared. So this will be A squared minus 2AX then plus X squared, because minus AX and minus AX will give us minus 2AX. So we'll write this as A squared minus 2AX plus X squared plus H squared. Now in the other triangle, the triangle ACK here, we can also apply the Pythagoras theorem here, and we'll get something like this. We'll say in triangle ACK, we can apply the Pythagoras theorem, which says the hypotenuse squared, this is the hypotenuse, the side facing the angle 90 degrees, the hypotenuse squared is equal to the sum of the square of the two other sides. H is one of the side and X is one of the other side also. So we'd say B squared is equal to X squared plus H squared. Now if you look at this, let's say this is equation 1 and this is equation 2 here. Now since we have X squared plus H squared here, and here we also have X squared plus H squared here, we can just substitute B squared for X squared plus H squared here, and this will be C squared is equal to A squared minus 2AX plus B squared. Now this B squared is representing X squared plus H squared that we have in equation 1. Okay, so we can just rearrange this as A squared plus B squared then minus 2AX here. Now if you look at this triangle here, you notice we still have X here, and we can do something about that. Now if you look at this triangle here, we can say in triangle ACK, we can take the cosine ratio of the angle C. We'll say cos C equal to the adjacent all over the hypotenuse. That's the cosine ratio. So if you take the angle here, which is C, we'll say that's going to be the adjacent. Cosine of the angle C is going to be the adjacent side divided by the hypotenuse. Now, this is the hypotenuse. This here is the opposite side. This is the opposite. Definitely, this is the adjacent side. So since cosine ratio is always adjacent all over the hypotenuse, so this will be x, which is the adjacent, x, all over the hypotenuse, which is b here. So let's say b. Now by the time we cross multiply this, we would have x is equal to b cos c. Now since we have x equal to b cos c here, we can just replace b cos c here for x, which is here, because x is b cos c here. We can just replace it here, and we would have something like c squared is equal to a squared plus b squared minus 2a. Now this is 2a here, but the x here is now b cos c, so we'll just say b cos the cosine of the angle c. Now this here is called the cosine. This is called the cosine rule. And if we try the same thing, we can also get a squared is equal to b squared plus c squared minus 2a, no, not 2a, b c. You notice here we have a squared and b squared. We also have a and b here, so it means this will be, since this is b and b here, it will be b, then the cosine of the angle, this will be a. Since we have a c here, the angle here is c. So we can also have b squared, it will be a squared plus c squared minus 2ac, then the cosine of the angle b. I'll just put b here. Now, so this is this is a cosine rule. This is a cosine rule, and we've tried this. This is for acute angle triangle. Now let's see if the cosine rule would also work for obtuse angle triangle. Now we'll call this acute angle triangle because all the angles here are less than 90 degrees. All the angles are less than 90 degrees. Sorry, 90 degrees. So let's say my angle is like this. Let's say my angle is like my triangle, not an angle. My triangle is like this. A triangle, my beautiful triangle. Okay, so let's say my triangle is like this. I'll produce this down as the height of the triangle. Just produce this down like this. Excuse me. So let's say this is A, this is B, and this is C. Now the triangle ABC is the obtuse angle triangle. We'll call this the obtuse angle triangle because this angle here is more than 90 degrees. This is an obtuse angle. It's more than 90 degrees. So that's why we'll call it the obtuse angled triangle. Obtuse angled triangle. So let's say since the side angle C is facing the side AB, so this would be small letter c. Let's just put a small letter c. Now since the angle B is facing the side AC, you can put this as small letter b. Now so that is like side B. Then since the angle A is facing the side BC, you can put this as A here, and let's take this here as K. So it means the height AK will be, let's just represent it as H. So the distance CK, you can just put this as X here. So just say the distance between, let me just do this like this. The distance between B and K would be A plus X. The total distance would be A plus X. Now from this triangle here, let me bring this down a bit. From this triangle here, I can say in triangle ABK, that's the big triangle, ABK, we can use the Pythagoras theorem here, and we'll have the hypotenuse squared. You know, the hypotenuse is the side facing the angle 90 degrees. The hypotenuse squared, which is c squared, is equal to the sum of the squared of the other side. This is one side here, and this is another side. That's for the big triangle. So this would be how it would be a plus x squared plus h squared. Now we can expand this. If we expand this like the way we did the first one there, we'll have c squared is equal to a squared plus, let's just do that, a plus x this would be a plus x, a plus x. By the time we expand, this is a times a will give us a squared. Now a times x will give us plus ax, x times a will give us plus ax. Now plus x times plus x will give us plus x squared, and this will be a squared plus ax will be 2ax plus x squared. So this will be s this will be a squared. Okay, no, let me bring this back. Okay, let me remove this here first. So this will be a squared plus 2ax plus x squared plus h squared. So now from the smaller triangle here, which is triangle ACK, we can say in triangle ACK we can apply the Pythagoras theorem here too. The hypotenuse is the side facing the angle, 90 degrees. That's this side, so that's B. So just say, let's say B squared is equal to the sum of the square of the other side, which is h and x here. So say we'll just put x squared plus h squared. So now since we have b squared as x squared plus h squared here, this b squared, which is x squared plus h squared here, can replace this x squared plus h squared there. So would have c squared equal to a squared plus 2ax plus b squared. So we can just write this as c squared equal to a squared plus b squared plus 2ax there. Now we can still do something about this x we have here. So what we'll just do here is we'll come to the triangle ACK, this small triangle ACK, and let's find this angle here. Let's find this angle here. Now you know this angle, this green angle here, this green angle is the obtuse angle, and let's say this angle here is C. Let me put this as C here. Now if this is C, let's say this other yellow angle, let me clean these things here, this R. Okay, so let's say this angle here is y. Now we need this angle y here. We need that angle y there. So we'll just say c plus y is equal to 180 degrees, because the sum of the angle on a straight line is 180 degrees. So it means that the angle y is going to be 180 degrees minus c. Okay, so we know that y is 180 degrees minus c presently. Now we can find the cosine. We can find the cosine. We can find the cosine of the angle y, which is 180 degrees minus c. So let's say 180 degrees minus c, which is equal to the adjacent all over the hypotenuse. You know, cosine ratio is always adjacent all over the hypotenuse. So this is the hypotenuse for the small triangle, this is the opposite, and this is the adjacent. So cosine is always adjacent, which is x, all over the hypotenuse, which is b here. That's b. Now here you know that for trigonometric ratios in the second quadrant, the cosine of 180 degrees minus c is still equal to minus cos c. So we can replace cos 180 degrees minus c with minus cos c. So this will still be, we can still say this is minus cosine c equal to x all over b. And by the time we cross multiply here, we'll have x is equal to b, that's minus b cos c here. Now you notice we have x here. Now it's because of this x here we've actually been doing all these things, because of this x here. Now you notice we have x here and we have this x equal to this. So let's just replace x for minus b cos c in this equation here. So we'll have c squared is equal to a squared plus b squared plus 2a into bracket minus b cos b c, that's the angle. So we have c squared equal to a squared plus b squared minus 2ab cos the angle c. So you see this here is a cosine rule, and you know that this is still the same thing. This we have here is still the same thing with what we got here. what we got here. So the cosine rule will definitely work for obtuse angle triangle and acute angle triangle. What we'll do is we'll use this the cosine rule to solve some questions on triangles in subsequent videos. But before we jump at solving questions using the cosine rule is used to solve triangles which are not right angle triangle, in which we have two sides and the angle between the two sides.